students, as we are seeing important questions for board, today's important questions from solution chapter. Okay, in that solution chapter, what are the type of questions you can expect? What are the main ideas from the solution chapter? Let us go and identify. First and foremost, concentration of the solution. In that concentration of the solution, expressing methods of concentration. In that expressing methods of concentration, molarity, molality, normality, these are the three main questions for practical as well as theory part also you will be learning from this topic. Right now, next point is solubility. In that solubility, solubility in solid and liquid, solubility in gas and liquid, and vapor pressure of liquid solution. These are the three main subtopics. In that, Henry's law from gas in liquid, Raoult's law from vapor pressure in liquid. These are the two main important questions you can expect from this subtopic. And the next one, ideal and a non-ideal solution. Definitely 3 mark question you can collect from here. And azeotrophs, that is 2 mark question. What do you mean by azeotrophs? Find out that azeotrophs mixture, like such kind of questions you can expect. And colligative properties, very important questions you can collect from here. Determination of molar mass and abnormal molar mass. That's all about this chapters important question. Only you can collect the important questions from here only. Anyway, exam oriented questions only we are going to see in this upcoming videos and today's topic also. Today's topic, what I'm going to take, it is concentration of the solution, that is expressing methods of concentration, mainly what it is, molarity, molality, and normality. And practical purpose also, today I would like to explain the calculation part, how to find out the strength of the solution. Like those are the points we are going to learn for all these sessions. Okay, come on, let us go and identify what are the main ideas for practicals as well as theory. Now let us go and analyze what do you mean by concentration of the solution. In that concentration of the solution, also known as strength of the solution, there are so many expressing methods of concentration. In that one among molarity. Why I have taken molarity here? Because it's very important for practical chemistry also. In that practical volumetric analysis, this is the main pillar of that. Okay, molarity in the sense strength of the solution or concentration of the solution. Okay, now how to identify the concentration of the solution? Okay, molarity is equal to number of moles of solute divided by volume of solution in liter. You know very well from smaller classes you have learnt solute, it is a solid substance. A solvent, it is a liquid substance, okay, which is dissolvable, that solute. Okay, now come to this point. Now, for example, you take 1 cup of milk. In that, you will add 1 teaspoon of sugar or 2 teaspoons of sugar according to your eye measurement or your according to your taste you will add. But in that practical chemistry, if you are taking 1 liter of water, in that 2 teaspoons of chemical substance or 3 teaspoons of chemical substance, if you add, you don't know the strength of the solution. So to find out the strength of the solution or to find out the concentration of the solution, we need some measurement. So we are weighing that substance and we are adding so and so in a liquid, that means 1 liter or 2 liters, according to that we are adding, and we have some calculation part. So if we know all these procedure, we will come to know the strength of the solution. Okay, now let us go and analyze what is molarity, how to identify the molarity, how to find out the strength of the solution, how to identify from known solution to unknown solution. These are all ideas. Just let us watch. Okay, first and foremost, molarity. Molarity, we just put capital M. Why you know? Because one more partner also it's available, that is molality. Molality, it is a small m that I will tell you later. Now molarity, it is a capital M symbol. So molarity is equal to number of solute divided by volume. Volume of solution in liter. Because we need measurement, for that is the reason liter we have taken. Okay, now capital M is equal to N by V I have written. V, it is what it is? Volume of solution. Volume of solution in liter. Right? Okay, now N, it is what it is? Number of moles. Number of moles of solute. Of solute. Okay, now number of moles, how to identify? See, small m, not capital M. Capital M, it is a normality. That is another one more partner is available. So, small n, it is what it is? Number of moles. So, number of moles, how to identify? Given mass of solute, that is given mass by molecular mass. Molecular mass of the chemical substance. So, given mass of this chemical substance divided by molecular mass of the chemical substance. Now, for example, number of moles, how to identify oxalic acid means given mass, they give 5 gram or 10 gram according to that. So, 5 gram or 10 gram divided by molecular mass of the oxalic acid. In that way, you will identify. Now we got that number of moles of the solute. Okay, now we have to check volume of the solution in liter. So, into volume of the solution in 1000, we can write it. So, how to write capital M is equal to given mass divided by molecular mass into V by 1000. Okay, so this is the formula for the molarity. Generally, they'll give one solution. It is a known solution, 0.1 m or 0.02 m. Like they will give the strength of the solution, that is 0.02 m. They mention that is the expression for the molarity of the solution. Okay, now there are some expressions are there, easy to identify. I have given a simple way. Please, if you want, you can take the screenshot or you please note down. That will always will help you. Okay, 1 m, it is actually the expression of the strength of the solution. Please note down. So 1 m equal to 1 molar solution. M by 2 equal to 0.5 m, that is a semi-molar solution, half. And m by 10, it is 0.1 m decimolar solution. M by 20, 0.05 m decimolar solution. You know, centi, deci, milli, like such kind of thing and all, you know very well. And m by 100, of course, 100 means it is centimeter and decimeter, decameter, hectometer, kilometer, like that and all. You have learnt that tabular. Now the same idea, you just bring it here. So m by 100 means 0.01 m molar solution, and m by 1000 equal to 0.001 millimolar solution. See, these ideas and all you can collect it from the objective type questions, because there are so many. To get that twisted way, to confuse way, they will give such kind of thing. So please note down and you just take that screenshot. That will always will help you. Okay, now one more main disadvantage here means molarity is dependent on temperature. So according to the temperature, the concentration will be vary. So that is what here one disadvantage. So the concentration will be ups and downs due to the temperature. So molarity is dependent on temperature. Okay, I would like to give one question related to this topic. Let us solve, then we will go for the practical, how to calculate that from known solution to unknown solution, a clear idea. Hope you got a better idea for these points. Now let us see one example. 2.46 gram of sodium hydroxide. Molecular mass, they have given sodium hydroxide molecular mass 40, right? Or dissolved in water, and the solution is made to 100 centimeter cube. So given volume also they have given. So volumetric flask, calculate the molarity of the solution. This is so simple. So molarity equal to what it is? Number of moles. Moles of solute. Number of moles of solute by volume. Volume of solution in liter. Okay, volume of solution in liter. So now we have to check it what it is. Number of moles of solute. So number of moles of solute what it is? Number of moles. Moles of solute, it is sodium hydroxide. So amount of sodium hydroxide. Amount of sodium hydroxide, how much it is? 2.46 gram. And given volume, volume of solution, volume of solution, so volume of solution it is 100 ml, right? We can turn into ml. Okay, now here given mass by molecular mass, no, number of moles equal to what it is? Given mass by molecular mass, right? So given mass what it is? 2.46 divided by molecular mass, how much it is they have provided? It is 40. So you will get 0.0615 moles. Small m, moles, number of moles. Okay, now here this is what it is given, number of moles you have found out. So 0.0615 divided by capital M, now we have to find out. So divided by, here what it is? Volume of solution in liter. So volume of solution, how much it is? 100 into 1000. So altogether you will get 0.615 mole per liter. Okay, so otherwise 0.615 molarity. In this way you have to write it. Hope you got a better idea about this. Now let us go and identify important practical related question. Okay, calculate the amount of Mohr's salt, FAS, that is ferrous ammonium sulfate, to be weighed to prepare 100 ml of M by 20 solution. Okay, now let us go step by step calculation. Okay, first and foremost, let us go for that 1 liter. After that 250, after that 100, like that we can go. So 1000, let us go for the 1000 ml. Instead of 1 liter, let us go for that ml way. That is 1000 ml of 1 m solution. Solution of what it is? Mohr's salt. Mohr's salt. That is FAS, ferrous ammonium sulfate, right? So, how much gram required to prepare 1 m solution in 100,000 ml? So, that means 392 gram. Why I mentioned 392? Because that is a molecular weight, that is molecular mass of ferrous ammonium sulfate. Yes, you got it. Okay, now for 1 n you are getting that much. Therefore 250 ml of M by 20 solution of FAS, the same FAS equal to 392 divided by 1000 into 250 into 1 by 20. 1 by 20 it is here, no? Okay, now you will get, if you calculate this, you will get 4.9 gram required to prepare 250 ml of that solution of M by 20. Okay, now 100 ml of M by 20 solution. This is for what it is? 250 ml. 250 ml. Please note that This is for 250 ml. Now it is 100 ml of FAS. Now what you will do, the same idea, 392 divided by 1000 into 100 into 1 by 20. Right? Okay, now this is so easy for you. This and this. So altogether 392 divided by 200. So you will get how much? 1.96 gram in 100 ml. Right? Okay. Now suppose you are getting the same idea, 100 ml of m by 40 if they are giving. See, one question only, there are so many ideas you are getting. So m by 20, m by 20, m by 40 solution. So this is actually a concentration of the solution of FAS. Okay, I hope you got an idea. So before I could write that sum, you are able to write. So here 392 divided by 1000 into how much? 100. That much we are preparing for that solution. So 100 into 1 by 40. So you will get what it is? 392 divided by 400. So you will get, what is the answer you will get? 0.98 gram in what it is? 100 ml. See, these both are 100 ml only. But you see, this is m by 20 and m by 40. That is very, very important. I hope you got a clear idea about calculate the amount of more salt to be weighed to prepare 100 ml of m by 20 solution. How much you require? How much you require for this? 1.96 gram in 100 ml of water. I hope you got a better idea about this. Now let us go and identify the calculation. It's very, very important for that. A1 M1 B1 equal to A2 M2 V2. What are all those points and how to apply the value and how to get the result? Let us go and identify. I hope you got a better idea about this point. Now the question continues. Using this previous question, using that molarity, calculate the strength and molarity of given K-manophore from known to unknown. So FAS solution, we know this molarity. Now you have to find out the strength and molarity of K-manophore solution. Okay, now this is completely redox reaction equation. Now let us write that K-manophore versus FAS equation. Okay, now here KMNO4 plus H2SO4 plus FeSO4 gives here K2SO4 plus MnSO4 plus Fe2SO4 thrice plus H2O. Now to balance this equation, 2 KMnO4, here 8 H2O, here 10, right? So here 2 and here 5 2s are 10 here and 8. Okay, now let us write that reduction and oxidation process. So you will come to know very clearly MnO4 minus, it gives here Mn2 plus. Right. Now here how many oxygen atom is there? That many water molecules. Now here if you write 2 means here also 2, here 8H2O. I hope you got an idea. And D and F block elements, I have given a clear idea about redox reaction. So please go through thoroughly because that's very, very important for practical as well as theory. Right? Okay. Now, the same way here, how many H plus ion? You have to write it here 16 H plus ion. And this is acidic medium only, right? Because it is H2SO4, naturally it is an acidic medium. And how many electrons it requires? See, here what it is? here plus 7 and here plus 2. How many electrons involved in that means 5 electrons involved. So you have to multiply that. For this is for reduction. Reduction. Reduction reaction. Okay, now this is Fe2 plus turns to Fe3 plus. So this is actually what it is, oxidation process. Oxidation. So how many electrons you have to multiply with? That means here only one electron, no? So you have to multiply with 5 electron. Why you have to multiply with 5 electron? Because to equalize. Already here 2 it is there. So 2 5s are 10. Here also 10 you will get it. Okay. Like that is. Right? Okay. Now come to this point. Here how many electrons? This 5 electron and this 5 electron it's cancelled. So here 10 Fe2 plus. It gives 10 Fe3 plus what it is? 2 Mn2 plus 8 H2O. Right? So this is a complete oxidation and reduction reaction. Okay, now let us go and identify A1 M1 B1 equal to A2. That is A2 M2 B2. Let us go and identify this complete equation. What are all applicable? Okay, here why I mentioned Kmn over here. A1 M1 B1 it is related to KMnO4. Here A2 M2 B2 it is related to FAS, ferrous ammonium sulfate. Okay, now let us check it. I'll rub this board. Now let us check A1 of M1 B1 is equal to A2 of M2 B2. Right? Okay, now A1 M1 B1 belongs to KMnO4. A2 M2 B2 belongs to FAS, ferrous ammonium sulfate. Okay, now let us check each and everything. A1 is equal to number of electrons gained per unit formula. So here how many? 5 electron. See, FeSO4, Fe2 plus converted into Fe3 plus, that is multiplied with what it is. How many electrons? 5 electrons. So to compensate here. Now here what it is? A2 equal to number of electrons lost per unit formula. Unit formula. How many electron? 1 electron. Okay, now A1, M1, B1 belongs to KMnO4 I mentioned, So in that way, here M1, it is molarity. So molarity of KMnO4. Molarity of KMnO4. This is only we have to find out. So let us put that question mark. Okay, now M2. M2 equal to, we know already, that is M by 20 already we mentioned. So molarity of FAS, ferrous ammonium sulfate. That is actually what it is, M by 20. Okay, now next to one, B1, it is volume of that. Volume of what it is? KMnO4. Yes, got it. So volume of KMnO4. See, KMnO4, you just put it here. Burette reading. Why? Because KMnO4 we fill in that burette only. So you just put it burette reading. So if you put Br means you will come to know what value you have to write it. For example, suppose if you are getting 10.8, second reading 10.7, third reading 10.8 means, so which is the concordant reading 10.8, that only you have to write it. Suppose if you are writing 10.8, ml you have to mention. You have to mention all those value. Okay. Now next one, v2. V2 what it is? FAS we will pipette it out, right? So volume of FAS. So that is pipette reading. Okay, pipette it is a 10 or 20 ml will be there. So according to that, you can put it that is 10 ml. Usually we will put 20 ml, right? 20 ml. Okay, now we got all those values A1, A2, M1, M2, V1, V2, all those values we have to go. We got it. Okay, now we have to find out what it is. M1 only we have to find out. So that is what purposely I have written M1 is equal to A2 M2 V2 by A1 V1. Okay. So you will get what it is. Molarity, you will get it. Now we have to find out the strength of the solution. Strength of the solution, it's so simple. Strength of the solution here, what it is? Strength of the solution of KMnO4. So strength of the solution of KMnO4 is equal to molarity. What answer you got it? Molarity into molecular mass. See here, strength of the KMnO4. So here what you will write it? Molarity. Here M1. This is M1, right? So M1 into 158. So 158 it is what it is? Molecular mass of KMnO4. So what is the unit you will provide? You will provide that unit gram per liter. Right? So this is the way you have to write the result. So you have to write the result that given unknown solution of KMnO4 is so and so gram per liter. So these are all the unit which is very very important. Okay. So these are all very important. Hope you got a better idea. In our next video, we will go through some more important questions from this topic, board related questions. Let us watch. Thanks for watching and please subscribe.